Good morning, everyone. This is Jim Chastain, Applications Engineer with EasyPower, and welcome to the EasyPower Tuesday Refresher. Now, admittedly, the title that we started out with for this webinar is a little underwhelming, and that's because it's something that we kick around probably every study or every webinar that we do. And so what I've tried to do is change the emphasis not in the reports that are generated as standard reports for the study, but frankly, the other uses for the data. And frequently, in talking to people, there is a lack of understanding or misunderstanding how to use or evolve this information, so that's where we're going to be focusing. So this will be short and sweet. Let's get into it. So our agenda primarily is to review the information that's required for a typical study, emphasize the fact that the arc flash hazard spreadsheet, while it's generated every time we fault the buses, it is the database that's used to customize the labels. While we're not going to be talking about that today, I do want to emphasize that we have 3 or 4 or more webinars that get into the details of how to customize labels and take full advantage of that large amount of data that's available to the label generator. What we do want to do today, and admittedly there's some amount of irritation on my part when people aren't taking advantage of that, is the ability to do equipment duty calculations, to be able to generate labels for OEM manufacturers prior to their being able to shipping the equipment, and then finally comparing the results from the 2 IEEE standards, 1584, 2002, and the 2018 in a relatively painless way using scenario managers. So let's get into it. So this is a slide that we use fairly frequently when we're talking about reports. And the idea is to, this is a list of recommended items that EasyPower suggests should be included in a standard arc flash study. Now, not the least of these includes number 4, which is the results of short circuit analysis listing the equipment that's applied above its short circuit current rating. This test we call equipment duty, and it cannot be generated if we don't have the right data in the database. So that's the thing I'm going to kind of preach about today. And secondarily, the results can be generated even across several different scenarios, because just like the arc flash instant energy calculations, when you change the configuration of the system, likewise you're changing the available fault current and potentially dealing with issues in the equipment duty side of things. The short circuit itself is intended to calculate the maximum worst case current at every bus in the system. And the reason for that is we want to verify that there's no point in the system that is violated whose withstand rating or the manufacturer's suggested max current is exceeded, because by verifying that, we can then use the manufacturer's guaranteed data sheet as far as performance when we're calculating instant energy. So first and foremost, we need to verify that this equipment duty feature is being utilized properly. Now, there's 3 ways to get there in EasyPower. One is to set a threshold of what we want the tool to examine, and that is, tell me if anything is above this particular threshold on the 1 line, and it will display that as a result. Secondarily, there's the equipment duty report, which we should be generating as a matter of procedure. And then thirdly, as I mentioned, using the scenario manager. So let's get into each of these and talk more about it. Now, if someone were to send me a 1-line diagram to basically review, one of the first things I do is verify that the database has a certain amount of information in it. One quick way to do that is to utilize the database browser. If I go under File and come down to Database Browser, the tool displays to me the description of the different elements grouped by their generic type, and I can look at those groupings. One of the first things I look at is buses, and what I'm looking for is specifically if there's a number in this particular column. And in this case, I see a couple buses that don't have data in it. This is the bracing value for that the manufacturer's nameplate puts on the equipment. And here's a case in point. I want to make sure that the main, because that's something that's going to be fairly critical in my examination, has a bracing number entered in there, and that we have the ability to verify it's not being exceeded. So for starters, I want to do this on every piece of equipment or every bus. Now, likewise, the same thing should take place, and this is a little bit off topic, but I also look at the low voltage breakers pretty much for the same reason. But here, I'm looking to make sure that we have a part number that can be retrieved. The data sheet can be retrieved from the device library. Again, we have at least 2 breakers here that haven't been filled in, so their equipment rating, while there's a number there, it's not necessarily valid because we haven't retrieved the data sheet from the device library. So these are just a couple points that I jump on first to verify that I'm not swimming upstream without a paddle. Now, once I've done that, if I go into my short circuit focus and I look at half cycle current, momentary current, and fault all the buses, the tool shows me what those maximum currents are. Now, obviously, to make sure that we're including motor contribution will give us a worst case available fault current in each bus. And if I look on the second row at the top here, this icon will allow me to present the equipment duty results. And if I click on it, the numbers disappear, except in this case for a -6, and it's flagged red by my fuse. Well, the reason this is flagged and has a negative number to it is the fact that I've set up a threshold. If I go to my short circuit options and look under control, the tool allows me to set equipment threshold duty. In this case, I've set a -10%. And I'm saying, okay, if any item in my system is within 10% of its rating, let me know, because I'm anticipating either a change in numbers from the utility company as far as available short circuit current, or I may be adding capacity to my bus, which could include or increase the available fault current at any particular bus. Now, so that's where the threshold in this -6 comes from. At the same time, we probably want to generate a short circuit report that includes equipment duty and includes all devices. And as we do that, we can see that it shows up in our list of windows. And here, in fact, we can see that the fuse indeed is still compliant as far as its withstand. It's rated for 55,000 amps, but it's only going to see 51.6 in a worst case condition, but that's where the -6% comes from. As I look at the other devices, everything's in pretty good shape and has plenty of headroom as far as equipment duty. Now, again, my pet peeve or my soapbox is how frequently these numbers are not included because people have not filled in that particular data block in the database format. So if I go back to here, and this can be done in the default setting. If we're using all square D panels, and we know for a fact that they're rated for 42,000 amps, we're going to be putting in several of them, we might want to go into our tool equipment defaults and set that up so we don't have to make that data entry at every point. Again, my point is missing the data, not having that data in that data block, we are not getting full value out of the EasyPower capabilities. All right, so that's equipment threshold, equipment duty. And then finally, we could do the same thing when I go back to short circuit focus. We could do the same thing with the scenario manager. I take that back. I need to be in database edit. Scenario manager can create a scenario for equipment duty results. And I'd want to change or save the changes. Basically, worst case comparison for all the buses and all scenarios. We're going to create a standard report, and this will show literally for every bus which scenario is the worst case. Now, in this particular example, I had set up and tried to bracket my best and worst case utility current, and certainly in every case, every scenario for every bus, that worst utility ends up being at issue. So, which I would expect. So again, my point is, it's there, and we should take advantage of it and know how to use it to our particular workflow. Okay, so that's basically what I wanted to, and I'm not accusing anybody of falling short in this area. I'm sure there's plenty of reasons that the equipment duty may not be an important part of the study, but my point is it's built into the tools, and so you're not getting full value if you really don't take advantage of that. Next point of order. How is it possible that an OEM manufacturer can produce an accurate arc flash label before they ship the equipment? Well, now the NFPA requirements, NFPA 70, suggests that or says that the owner of the equipment is responsible for accurate arc flash labeling. And as a result, many contracts, either by large organizations for test equipment or campuses for even medical equipment, the contract may have a clause that says, okay, before I take title, this equipment needs to have an accurate arc flash label on it. So my question is, how can this be done? And the answer is we can utilize the data that's provided during a short circuit study. So if I go back to my example here, and I know I'm an OEM manufacturer of equipment, and I know my end customer is going to be mounting or plugging that equipment into this main bus, and I need to have a label on it. I know for a fact there's going to be a breaker, a cable, and then another breaker into my box. But what do I do for arc flash calculations before, especially if I don't know anything about the equipment, the client side stuff? Do I need to go in and do a full arc study to be able to label my equipment? Well, the answer is no. If I go into short circuit focus and I fault this bus and I create short circuit reports, in this case I'm going to undo the equipment duty report and create a high voltage and low voltage momentary report, we can see that now that report looks something like this. What it tells me on the main, if I can find the main, here it is, that it's a 480 volt bus. The available short circuit current is 21,187 amps. The X over R ratio is 5.59. These are the factors that I need to be able to produce this end label without any other information from the tool. So I'm going to go in and copy this down so I don't forget it. And my purpose, my end goal is now to substitute this information in for the utility in a new one-line diagram that's going to represent my box, my control system that I'm going to sell to the customer. Okay, so here's the representation of what the system will look like, at least my portion of the system will look like when I deliver the control system, the box I'm going to sell. My load down here is 100 kilowatts and 100 kilobars. I'm going to have a 480 volt delivery system. I'm going to have a multi-K circuit breaker as my main. I'm going to have a 50-foot cable that's hooked up to the point of connection with the client, and he's going to provide a breaker that's going to have these same parameters. Now, what I want to do is represent, instead of an infinite bus like we have up here, represent what that available short circuit current is at the manufacturer's site or my client site. So I'm going to go up now and change my utility icon to be one of point of connection with my client. It's 480 volts. It's 21.18 kiloamps available, and it's 5.59 X over R. Now, failing having the specifics for the single line to ground, I'm going to use the same numbers because this will be worst case. And what this does for me now, of course, I need to get it right. This allows me to basically simulate what my system will see in terms of available short circuit current and impedance match when I get it built in the field, when I get it delivered. So now by doing this, I can go in, do my own short circuit study, look at fault current. My system's subjected to 17,000 amps maximum. I can look at the instant energy. And now I have a realistic value that can be put on my OEM equipment. Now you might say, well, did I really need that? You know, that's a good point. And just for example's sake, let's go back and try it out. Can I get away with the same information by just using an infinite source? And my suggestion is, let's kind of get rid of this guy. My suggestion is possibly, but so it's more than double what it was when I use the actual numbers. So the answer is yes, I could probably get away with it if I have a relatively small system and a relatively benign connection point. But accuracy will win out by utilizing those short circuit numbers from the client. So I promise this will be short and sweet. So we're getting down to probably the biggest subject that people have an interest in, and that is comparing the results of IEEE 1584 old standard versus new standard. I'm going to do this with the scenario manager, and the steps involved is create a new scenario with the updated standard as part of the analysis, create a new report form to compare specific scenarios, and to do this I'm going to use the same example that we've been working with. Now, you may not have noticed, or I may not have shown this earlier, but if I go into short circuit focus on this example and I look at the options, my arc flash hazards, this was an example that was actually built prior to 2018, and so everything I've done so far with the scenario manager has involved the analysis using 1584-2002 and momentary current. I want to make sure I'm in the base case and everything is saved under the base case. And now I want to change my standard now to 2018. I want to use integrated method. I want to apply this. Now I'm going to go back to my database edit. Actually, let's go ahead and save the scenario. I'm going to store the scenario as, let's call it 1584-2018. Looks like I've already done it once. All right, now when I go back to database edit, go ahead and save the changes. I'm going to go into scenario manager, and I'm going to create a new scenario comparison report for arc flash. And I'm not going to save any changes here. Now we're going to use a default view, but rather than, and we want to look at all the different equipment rather than just a select one. So it looks like I've already created a scenario. What you want to do is come down here to scenario group and go to the settings file and create a new scenario. In this case, let's just delete it and start from scratch. I'm going to come under the all scenarios and add, and we're going to call it standard comparison. And once I've got this labeled, Now I want to include the base case, which I know was done under 2002, and that example I just saved, which is configured under 2018. And I'm going to save the changes. Now when I come back to my choices, I want to select comparing standards and then create the report. And now, without any further ado, for every case, I'm comparing 2002 with 2018. And because I've done this before on this particular example, virtually every bus, the 2018 version gives me more or less conservative results. So the incident energy has gone down, some by a little and some by a lot. So here we go from 1.2 to 0.8. Here we go from 0.5 to 0.2, but it kind of answers that question fairly short and sweet. Okay, so that's what I wanted to touch on today. Thank you everyone for joining us. We will take questions via email. Certainly you need to check the website. We have the first part of the year training locations set and announced. We have online training, which can be an economical alternative to the regional training. If you have questions about any of this stuff, you're welcome to contact tech support at easypower.com. And certainly if you've got questions, you can send them to me, Jim at easypower.com, and we will answer them as best we can. Hope you all have a good day, and we'll talk to you down the road. Thank you very much.